Hey, Austin. Um, on this example that you emailed me, we're being asked to find the integral from 1 to infinity of 7e to the negative 7x with respect to x. So this is called an improper integral because one of our limits of integration is not an actual number. We can't actually just plug infinity in for x because infinity is not really a number. Infinity is just it's just the idea that we're allowed to continue on forever in the positive direction. So we don't have to really worry about that infinity until after we find our antiderivative. So the very first thing you should do is just find your antiderivative here. You can this is a composite function, so you're going to want to write out a u substitution for your exponent. We're going to let u equal negative 7x. That means du is going to be negative 7 dx. And we do have a 7 in there that we can get rid of, but we don't have a negative. So I'm going to divide that negative over to the other side. And we get negative du can replace the 7 dx. And then this turns into negative e to the u du, because 7x turned into u. And then the 7 dx is equivalent to negative du. So we've just got negative integral of e to the u du, and the antiderivative for e to the u is e to the u. Before we evaluate, we need to write this back in terms of x. So we've got negative e to the negative 7x, and we want to evaluate this from 1 to infinity. Now, technically, when we evaluate at infinity, we have to think of it as a limit. So we can't just say e to the negative 7 infinity. We've got to write the limit as x approaches infinity for negative e to the negative 7x. That's what we get when we plug our top bound in. And then you subtract whatever you get when you plug the bottom bound in. If we plug 1 in, we get negative e to the negative 7. So negative e to the negative 7 is just a number. What we need to figure out is what happens on this negative e to the negative 7x graph when the x goes to infinity. So what you can do if you want to is you can type this function into your calculator and see what happens as the x values get larger and larger and larger and larger. What I'm going to do here is I'm going to open up Desmos and take a look at this graph to see what's happening. So we've got negative e to the negative 7x. So that's the graph that we're looking at. And we are interested in what's happening as x goes to positive infinity. So if you look on this graph, the x values get bigger as you move to the right. And no matter how far to the right you go, that graph is staying pretty much on the x-axis. And the x-axis has a y value of 0. So it looks like the limit as x approaches infinity on this function is equal to 0. So this entire first piece we just figured out by looking at the graph. On this negative e to the negative 7x graph, as x gets really, really, really large, the y value is going to 0. And then we've got a minus and negative here is going to change to a plus. So we just say plus e to the negative 7. And in MyLab's Plus, 0 plus anything is itself. In MyLab's Plus, they rewrote this. Anytime you have a negative power, that means you can take this and move it to the denominator and change it to positive. So that's why MyLab's Plus got 1 over e to the 7th.